Okay, this is day 2 of 5.3. It's a lot of numerical calculations. It might be handy for you to have your, let me get it right here, your 5.2 day 1 notes. I'm going to reference the back with the mini tab output today, so it might be handy to have those out. So if you want to pause the video and get that out, that would be helpful. So yesterday we talked about how the residuals just tell you if the linear model is appropriate or not. Today, like I said, we're going to look at two sort of numerical ways to look at it. These are both, the two things we're going to look at today are things that you will need to memorize. You need to memorize the interpretations. You're never really going to have to find them on their own, but you do have to memorize the interpretations. So the first one that's new is called the coefficient of determination, which is r squared. So we've really been focusing on r. Now we're going to look at r squared. R squared is a measure of the proportion of the variability in the y variable that can be explained by the linear relationship between x and y. So for example, suppose we open a pizza parlor selling pizzas for $8 plus $1.50 per topping. If we were to plot the points 0, 8, 1, 9.50, and 2.11, they would fall exactly on a line. So in this case, the number of toppings explains 100% or all the variability in the price. So r squared is 1. So how do we find r squared? Now, here's where it gets a little technical. Some of this stuff I'm going to try and explain, like this is what you need to know, some of it you don't. So the following variables are used in the calculation of r squared. So we have SS total, SS model, SS residual. So if you, okay, I have to think about this. So let's say you have your scatter plot. Okay, I'm going to zoom in so you can see. I'm trying to show you the difference between all three of these things. So you have your least squares regression line. Okay, and then you have this line here. This is y bar. Okay, that's the average y. So you have like a lot of dots going on. So you'll have a y. That's your actual y value. Then underneath that, on the line, you have y hat. That's your predicted. And then down here, you'll have y bar. So you have each one of those for a particular x value. So the difference between y and y hat is the residual. Now if I square all of them and add them together, I'm going to get SS residual. So if I take all the residuals, I square them, I put them together, I get that. The distance between y hat and y bar, if I were to square it, add them all together, this would be SS model. Okay, the total is the difference between y and y bar squared. So if I take that distance, square it, add it together, I get the SS total. So there's two different distances, and then the third one is them added together. So we calculate all of this to help us figure out r squared. Now you're never going to actually have to figure out all these numbers because it's really like too far into the course. So SS total is the variability in the response variable. So again, the difference between y and y bar. SS model is the variability in the response variable that is accounted for by the explanatory variable, or the difference between y hat and y bar. SS residual is the variability in the response variable that is not accounted for by the explanatory variable, or again, the difference between y and y hat. So really what you need to know for r squared is you need to know the interpretation. So again, it's a percent of the variation in the response variable, so the y, that can be explained by the linear relationship between y and x. Or you can tell me x and y. So again, you're not going to actually have to find these in the calculator. So I have randomly selected 10 students from this class and recorded their heights and their weight. You can calculate r squared by hand if you're given data from the mini tab output. So if you get your 5.2 day 1 notes out, let me show you where it is in the mini tab output. Now this is obviously for different data, but it'll show you where the stuff is. So you have your analysis up here, and then you have your analysis of variance. SS is what you're looking for. This number here is your SS residual. Notice it says residual error here. So sum of the squares, residual. This one is SS total. Those are the only two you really need to know for the two equations I'm going to give you today. You do not need to know. This is SS model, but you don't really need to know it. The other thing you will need to know, and I didn't go over this in the last video, degrees of freedom here, DF. This total, this one is always n minus 1. So n here is really 6. Okay? So that'll help you with some of the homework tonight. Because a lot of times, instead of me trying to have you do this in the calculator, I'm just going to give you this stuff, and you have to find r squared and the other one we're going to do today. Okay, so if I find r squared, here's the formula you need to know. Now this is one of the formulas that's not on the formula sheet. So you do need to memorize it. So it's 1 minus SS residual over SS total. Now I went ahead and found SS residual and SS total for you. So it's 1 minus 3828.9 over 14,096.4. So I'm going to do that in the calculator. And then we do 1 minus. So I get an r squared of 0.728. So calculate, interpret the correlation coefficient. So here's our interpretation. So 72.8% of the variation in a student's weight can be explained by the linear relationship between a student's height and weight. You can really interchange X and Y there. So 78% or 72.8% of the variation in a student's weight can be explained by the linear relationship between height and weight. Okay, so let's think about what from yesterday. Do the scatter plots from yesterday's notes, where the lines summarize the data about well as possible, correspond to the highest values of r squared? If I look, we said 1 and 4 were the better ones. 1 and 4 really don't have large r squared values. So we really don't look at r squared when we're looking at does it fit. Really what you should look at, so you can't rely on r squared to determine if a linear model is appropriate. We have to go back and look at the residual plot. Okay. The other one that we talk about is the standard deviation of the least squares regression line. So this is like the last thing that you're going to have to memorize. So to get a sense of how close points are to the line, we can calculate the standard deviation about the least squares regression line, which gives us an estimate of the average distance each observation is from the line. So really we're calculating the average residual. So again, remember the residual is from y to y hat. So if I take all these and I find the average, that's what SE is. So it gives you the variability around the line. So again, here's the formula. And it's not on the formula sheet. It is, however, sometimes on the mini tab output. So again, if you go to your 5.2 notes, this S here, this is your standard error, which is what we call standard deviation. So this is the one you're looking for. So it's right underneath that age. It's right. So we looked at R squared and we looked at S. So they're right next to each other on the mini tab output. or you can use SS residual n minus 2 square rooted. So here's your interpretation. The value of S measures a typical amount of variability in the vertical distances from the Y value to the least squares regression line. So if I want to calculate and interpret the standard deviation for my weight versus height, sometimes you can put SE or you can just put S. I'm going to take 3828.9 and I'm going to divide it by, we did 10 students, so 10 minus 2. And I don't know why it's 10 minus 2. I assume it's because it's bivariate data, but I don't really know. So I get 21.88. So if SE is large, you have a lot of variability. If SE is short, you have a small amount of variability. So here's my interpretation. So the value S equals 21.88 measures a typical amount of variability in the vertical distances from the student's weight, that was our Y value, to the least squares regression line. And you can write it out as the regression line like I have typed, or you can just put LSR out. It's totally up to you. So you do have to memorize a couple things. So for your test, you should have memorized how to interpret. You need to know how to interpret R, slope, y-intercept, R squared, and SE. So those are the 5 basics. Again, it's a pure memorization technique. I like to just put them on note cards and just repeat them to myself over and over again. And that kind of helps me. So that's really it for day 2. We're just focusing on those 2 new formulas and their interpretations.